Hello everybody. Today I am going to discuss a GATE 2024 analog electronics question where you have seen that there are two op amps are given and then there is an inductor and other are resistors, and both the op amps are connected to plus 10 volt voltages and minus 10 volt voltages, and it has been said that the initial inductor current is 0 ampere and you are applying an input voltage which is a triangular signal which has a peak voltage of plus minus 2 voltages, and you have a time period and the input time period is 8 microsecond. Now you have to just figure out that what is VO1 is and what is your VO2 is. So before starting that, one thing I need to tell you that if you see about the op amp A1, OP A1, you are seeing that it is connected in a positive feedback. There is no negative feedback. If an op amp is connected in a positive feedback, then there is a no question that the error should be 0. So what I am trying to say, that the difference of the voltages between the non-inverting terminal and the inverting terminal of op amp A1 that should not be equal to 0. They should not match with each other. Okay. But if it is a negative feedback, then there is a possibility that both the voltages will be equal. And if both the voltages are not equal, so then the op amp is going to saturate. If your V plus is greater than V minus, then your output voltage will be plus 10 volt. It will saturate. And if your V plus is lesser than V minus, then your output will be minus 10 volt. First, let's focus on solving the op amp A1 part and then we can go to the next part. So in the op amp A1, if you apply superposition and see that what is your V plus, because I said V plus greater than V minus, here V minus is 0 volt. So if your V plus is greater than 0 volt, output will be plus 10 volt. And if your V plus is lesser than 0 volt, then your output VO1 will be minus 10 volt. So first we need to find out that what is my V plus. Okay, so if you apply the superposition and you just activate only one source at a time, say only VO1 is activated and VI has been shorted, it is set to 0. Then as per the voltage division, you will see that V plus is nothing but the voltage which is across the 10k ohm resistor which is now connected to ground. So it is a ratio of 10k divided by 10k plus 100k. Similarly, when there is only Vi and your VO1 is shorted to ground, so then it is nothing but the voltage, the ratio of 100k divided by 10k plus 100k. Okay. So now we need to find out that what is the value of Vi for which there will be a transition in the output from plus 10 volt to minus 10 volt. So as we know that this op amp is already saturated because it is in positive feedback. So we have to find out that at what value of Vi your V plus is going to be first 0 and then it will be lesser than 0. Because if you see this equation, then you will see as Vi is decreasing, your V plus will also decrease. Okay, so slowly your V plus which was initially greater than 0 volt, now it will approach towards the 0 volt and then it will become 0 volt and then it will become much lesser than, means it will become lesser than 0 volt, and once it's become lesser than 0 volt, your output voltage VO1 will be minus 10 volt. So that voltage is your VHL, means the voltage at which input voltage which is trying to make the output from high to low, means from plus 10 volt to minus 10 volt, and that if you compute, that will be minus 1 volt. Remember these things are going to be very important for us in the upcoming slides. Similarly, the input voltage which is going to make the V plus greater than 0, means initially the V plus was less than 0, then it will become equal to 0 and then it will become greater than 0. The V plus will be greater than 0. So that input voltage which is forcing, if you calculate, that is plus 1 volt. Okay. So first what we need to consider? We need to consider that our initial voltage was minus 10 and then up to which value of my input my V plus will be 0. That is my transition point. Similarly, in the previous case, what we have did for in the output voltages, instead of minus 10, here we have considered minus 10. Over there, we have considered plus 10. And we have found out that what is my transition. Okay. So here you can see that there is a hysteresis also. So as my input is varying from minus 2 volt to plus 2 volt, I can see that there is a transition of output from minus 10 volt to plus 10 volt, but there is already a hysteresis and it is nothing but a Schmidt trigger. Okay, and because of positive feedback, it is always going to be saturated. Let us assume my initial VO1 voltage is minus 10 volt and my V plus was less than 0 volt. Okay, as my input which is covered as a, which is given with a blue line, is which is a triangular waveform also, crosses plus 1 voltage. Then my V1 crosses 0 voltage and becomes greater than 0 voltage. Then my output flips from minus 10 volt to plus 10 volt. Okay, and then what happens? It continues, and when my input decreasing from plus 2 volt to minus 2 volt, and when it crosses minus 1 volt, then what happens? My V plus changes from a positive value, it becomes then equal to 0, and then it decreases further and it becomes lesser than 0. Then my output flips from plus 10 voltage to minus 10 voltage. So the circuit which is given, the first part, which is the op amp 1, is nothing but is generating a square wave which has a period of 8 microsecond. Okay, and if you compare the both input and the output, you will see that the output is delayed with respect to input by 1 microsecond, because you can see that the positive value of the input is for 0 to 4 microsecond, but there in the output your output is positive from 1 microsecond to 5 microsecond, so it is delayed by 1 microsecond. Now we have to find out that what is VO2 is. As I told you that the op amp A1 is having a positive feedback. Similarly, op amp A2 is having a negative feedback. If there is a negative feedback and it has been said that the op amp is ideal, so your op amp has an infinite gain. If it has an infinite gain and your output is finite, because maximum it has to be plus 10 voltage and minimum it can be up to minus 10 voltage. So your input, which is the error V plus minus V minus, that has to be equal to 0, which means your V plus and V minus are equal, and that is equal to 0 because your V plus is already connected to ground, so your V minus will also be 0. Okay, so this is the fact that there is also a virtual ground at the inverting terminal. This concept we are going to use while finding out VO2. See the second op amp circuit. So VO1 is a square wave which you are applying, and it has an inductor, and then there is a resistor. Okay, but one thing I want to say, that since the op amp is ideal, so your open loop gain of this op amp is infinite, but your output can be in between the range of plus 10 volt and minus 10 volt. So your output is finite, but your open loop gain is infinite, because in the question it is given that it is ideal. So your error or the input which is your difference between the positive terminal and the negative terminal, has to be 0. So your V plus and V minus both are equal. So your V minus is becoming equal to 0. So that is, your V minus is becoming virtual ground. So this op amp is forcing this inverting terminal to be virtually grounded. Okay, so now what is happening? So the entire voltage VO1 is appearing across the 1 millihenry inductor. Okay, that is inducing a current which is going to flow through that 1 kilo ohm resistor, and this current which is going through the 1 kilo ohm resistor is going to induce VO2. Here there is another term, that is I naught T. This is the output current from the op amp terminal. Okay, so we are just ignoring it, and we are just, for simplicity, we are considering that at T equal to 0, although there is no switching circuit given, but we are considering that at T equal to 0, my output VO1, which is actually the input to the second circuit, is minus 10 volt, and my inductor current is 0 ampere. And the current which is flowing through the inductor can be calculated by this integration, where you can take like a time integration from 0 to T, where your T is less than 1 microsecond. One thing which I want to say, because for that time my voltage is minus 10 voltage. Okay, so if we then calculate that what is my current at 1 microsecond, it should come as minus 10 milliampere. Okay, so already I have defined that my voltage at the inverting terminal is 0 voltage. So my output voltage is minus ILT, because the current is coming in opposite direction, into 1 kilo. And my voltage, output voltage VO2, can be within the range of minus 10 volt to plus 10 volt. So as we have seen that at 1 microsecond, my current, inductor current, is minus 10 milliampere. And if you see VO2, that is my plus 10 volt. So this is the maximum value which is possible. So we have verified that yes, the output voltage is within the range of minus 10 to plus 10. Okay, so my VO2 at time 0 to 1 microsecond is positive 10 to the power 7 T. also one point I want to mention, that if your current is so high that that it is trying to make VO2 much greater than say 10 or plus 10 or minus 10, it will never happen, because the op amp will saturate and maximum supply it can give plus 10 and minimum supply it can give minus 10. So the op amp will be saturated, and then that virtual ground concept will not be applicable. So B minus might not be 0. This question might be looking like that it needs too much of pen and paper work, but it is not. More you practice this type of questions and more you have a good concept, it will not take much time. Okay, so just follow what I am saying, and after that you will be able to visualize it in your mentally, you will be able to visualize. Okay, so at 1 microsecond to 5 microsecond, again what is going to happen, my VO1, which is my input to the second op amp, is plus 10 voltage. Okay, and already there is an initial current which at 1 microsecond, that is minus 10 milliampere. Now my inductor current is going to increase linearly, that is of no question. But what is going to happen, if my inductor current is increasing linearly, then my output is also going to increase linearly, although there is a negative sign. So at 1 microsecond my voltage was plus 10 voltage. Now at 3 microsecond my output voltage, which is VO2, will be minus 10 voltage. Now it cannot go further down. VO2 cannot go further down because it is already restricted to plus or minus 10 volt. So now what is going to happen? My inductor current is going to increase. But my output VO2 cannot going to increase. So it will be constant for a particular time. So from 3 microsecond to 5 microsecond, what is going to happen? My inductor current will increase, but my output will be constant. And your op amp and our op amp, which is op amp A2, that is in saturation, and my V minus is not equal to 0. And we will also see that how it is working. Okay, so here is a circuit where I have shown that within 3 microsecond to 5 microsecond, how means my V minus is not going to be 0 and it will be greater than 0. Only at 3 microsecond it will be 0, but at 3 microsecond it was actually from 1 microsecond to 3 microsecond, it was actually linearly, means my inductor current, it was also linearly increasing, and my output voltage was also showing, VO2 was also showing a linear behavior, although it is going downwards from plus 10 to minus 10, but still at 3 microsecond, at the onset of 3 microsecond, still the virtual ground was applicable. But when it crosses 3 microsecond, when the time instant is greater than 3 microsecond, then my virtual ground concept is not applicable. Okay, similarly at 5 microsecond my inductor current was 30 milliampere, because inductor current cannot change instantaneously, but my input has already been flipped from plus 10 volt to minus 10 volt. So now what is going to happen? My inductor current is going to fall down, but it will linearly fall down. So at 5 microsecond my inductor current will be 30 milliampere, and at 7 microsecond my inductor current will be 10 milliampere. But still, if this 30 milliampere, even if it flows, still my output voltage VO2 will be at minus 10, and up to 7 microsecond my VO2 will be minus 10 volt, because the op amp is already at saturation. Okay, so here is also the same diagram where you can see that my V plus is greater than 0. Only at 7 microsecond it becomes 0. So what is going to happen? From 3 microsecond my V plus is going to increase from 0. At 5 it will become particular value, and then from 5 to 7 it is again going to decrease back to 0. So at 7 microsecond my V minus will be equal to 0. So at 7 microsecond my inductor current is 10 milliampere, and then again it going to further decrease, because my voltage is already kept constant at the inductor. Okay, so already the voltage is going to, since the voltage is already kept constant, so my inductor current is going to increase further down. And when the inductor current is going to decrease down in the time period of 7 microsecond to 9 microsecond, what is going to happen? It can then, the op amp is acting as an amplifier. At that time our virtual, because there is a negative feedback also through that resistor, which will force, and also it is also a ideal op amp. So this ideal op amp will allow the inverting terminal again to be at 0 voltage. I hope this is clear. Okay, so it is clear that our output VO2 is a trapezoidal waveform, and my VO1 was also delayed by 1 microsecond with relative to VI. So my answer is option D. Okay, I think this is fine. Okay, and if you have any doubts, then let us know. We can discuss about it. Okay, thank you. All the best.